bunch of different objects, a Newton meter, a plastic cup with some string, and a mass balance. That's what we're going to need today to calculate the strength of gravity on Earth. Step 1. Take your first object and place it on the mass balance, then record its mass. Remember, to convert grams to kilograms, you divide by 1,000. Step 2. Hang your plastic cup from the Newton meter, put your object in the cup, and measure its weight in newtons. Step 3. Repeat those first 2 steps for all your different objects. Step 4. Now we're going to use our results to plot a graph with mass on the x-axis and weight on the y-axis. On the graph I've given you, each big box on the x-axis represents 0.02, and this is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares. That means each little square is worth 0.02 divided by 10, 0.002 kilogram. On the y-axis, each big box represents 0.2. It's also divided into 10 small squares, so each of those is worth 0.02. Now we've figured that out, we can plot our points and draw our line of best fit. The final step is to find the gradient of the graph, because the gradient of the graph will equal the strength of gravity on Earth. To begin with, take 2 points from near the ends of your line of best fit, from the extremities. Then join them together into a right-angled triangle. My favourite way of writing down gradient is dy by dx. The d is the Greek letter delta, and delta means change in. So dy by dx means change in y divided by change in x, which is how we calculate the gradient. Our y value started at 1.32 and finished at 0.2, and the x value starts at 0.13 and goes down to 0.02. Take the little number from the big number to find the change. So our gradient's going to be 1.12 divided by 0.11, that's 10.2 newtons per kilogram. At G.C.S.E, we round Earth's gravity to 10, so 10.2 is pretty close. In reality, it should be 9.81. So see if you can do the experiment more accurately than me and get closer to the true value. Good luck!